Okay, in this video, I am working another inclined plane problem. So, again, here's my equations up here at the top. So, Riley pushes a 600 Newton box. All right, so that means that's our inanimate object. So our force of our resistance equals 600 newtons. Box up a 10-meter long slope. So we know that that is our distance of our effort, because the slope is always the effort, all right, of 10 meters. That elevates the box a vertical distance of 1 meter. Vertical distance is the same thing as a height, all right? So that means the height is always the resistance distance of 1 meter. So that means we don't know our force of our effort, because it said for A, what is the force that Riley must apply to the box to move it to the top of the slope? Again, we're looking at Hogantopia here on paper. We have to assume that IMA equals AMA. So if I'm assuming that IMA equals AMA, then we say force resistance over force effort equals distance of your effort over distance of your resistance. So I'll plug it in. 600 newtons over X equals 10 meters over 1 meter. Meters cancel out. When I cross multiply, I'm going to multiply 600 times 1. Then I'm going to divide it by 10. So that's going to give me 60 newtons. All right, so Fe equals 60 newtons. So the next question says, what is the IMA of the slope, and what does this mean? Okay, so the IMA of the slope, IMA equals distance effort over distance resistance. So that's 10 over 1 meters. Meters cancel out, giving me a 10 for my IMA. All right, 10 times easier. Right, so what is the AMA of the slope if Riley actually pushes the box up the slope with 200 newtons of force? Well, that's a big difference than the 60 newtons. So we need to find AMA. Friction is figuring in. If you think about pushing a box or pushing something up a slope, there's a lot of friction. So we expect something like this. So that's force resistance over force effort equals force resistance. The box still weighs the same, 600 newtons. But this time it took him 200 newtons, or Riley could be a girl's name also, so he or she, 200 newtons to push it up instead of what we expected. Like I said, Hogantopia is always better. All right, 60 newtons in Hogantopia. But, so we figure that, and it is 3. So our actual mechanical advantage is 3. Again, big difference, but it is still easier to push it up the slope than it is just to pick it up. All right, so what is the efficiency of the slope? So let's move it on up here. AMA over IMA times 100 equals, so AMA was 3 divided by IMA, 10, times 100. So that would be 0.3 times 100 is 30%. We lost a lot in outside forces on this particular one. All right. So, but 30% is our efficiency of this slope. I don't know if Mrs. Krumtek's going to work any of these. They seem like pretty easy problems, and it's kind of the same thing you've been doing for all the other ones. Let us know if you need us to work some more so we can go ahead and get some more videos done for you. Okay, good luck. I think hopefully you guys have been getting this down so far.